Hey everyone, we're just going to do a really quick review on kind of the anatomy and physiology of the kidney. So the main purpose of the kidney is to filter the blood, right? So it will, the blood goes to the kidney, it basically separates all the wastes, the things that we don't need in the body, from the things that we do need, and will reabsorb the things that we do need back into the bloodstream, and the rest of it, the waste, comes out in the urine. Okay, that's the basic gist of it. It also does these other, these are the other big things that it does that's important. So one of the things is that it's responsible for producing erythropoietin, which is a hormone that stimulates the production of red blood cells in the bone marrow. Okay, so if your kidney's not working and you're not creating the erythropoietin, you're not going to have your red blood cells continually being replenished. And if you remember from your hematology or whatever courses, that red blood cells kind of have a life cycle, right? I can't remember exactly how long it is. I should know that, but I don't. But as those red blood cells die off, new ones are created, right? So we always have the necessary amount. If your kidneys are not working and they're not releasing that erythropoietin, as those older cells start to die off, your body isn't creating as many or at all any new red blood cells, and you become anemic. Okay, so the other thing that's really important that the kidneys do is they activate the vitamin D in your body, and I believe that it's the only organ or part of the body or whatever that does activate that vitamin D. And that vitamin D is necessary for calcium absorption. So all of the calcium in your bloodstream, in your body that you need, comes from external sources, from food. So most of it is it's absorbed in the GI system, right? And so about 30% of what you eat, the calcium that you ingest, is absorbed through your GI system, but it needs vitamin D to do that. There's a whole complicated way of looking at that. It doesn't matter for our purposes. We just need to understand that. And so if the kidneys are not working and they're not activating vitamin D, then you end up with low calcium. And we'll talk about that in another video. And then the last thing is the renin. And I'm not going to go through this in detail because I know that you guys took this in probably your fluid balance and your acid-base balance. But the idea of renin basically helping to regulate your fluid balance and your blood pressure. Okay. So let's talk about what the kidney is made up of. I don't think you need to worry about all these different layers. So I'm not going to go through them. But basically it's made up of a bunch of, or millions of, cells called nephrons. So it's just like in your neural system, right? You have neurons. These are just nephrons, okay? And the purpose of the nephrons is to do exactly what I just talked about, which is to filter the blood. So the nephrons look like this, kind of. This is a kidney, so don't worry about that. And so as the blood comes into the kidney, okay, some of it is going to be used to perfuse the kidney. We've talked about that yesterday, and some of it will be filtered. So basically this process works kind of like this. So the blood comes in. The first place it hits is the glomerulus. This here, I'm going to use this diagram down here. I just find it easier. This here, this little where is it here? Oh, actually it's pictured better here, but okay, we'll use this for now. is the glomerulus. Okay. And the glomerulus is basically a bunch of capillaries with semi-permeable membranes. Okay. And you remember from your fluid-based balance how water shifts, or fluid, sorry, I keep saying water, fluid shifts in and out of the vascular system largely through using hydrostatic pressure. Okay, so that's happening inside of that glomerulus, and basically what's happening is it's pulling out or pushing out everything in the blood, not everything, but a good chunk of things in the blood that is not red blood cells, platelets, or really large proteins. Okay, so it filters by size at that point. Okay, you probably don't need to know more than that. The glomerulus will filter that blood, and it doesn't filter all, like it doesn't filter, not all of the blood is filtered, not all of that filtrate or whatever's coming through is filtered in the glomerulus, just the beginning, right? But it's a really important part because a good chunk of it is. So it filters blood at a rate of 125 milliliters per minute. Okay, so that's the rate it's supposed to go at, and that is your glomerular filtration rate, which is your GFR, and we'll talk about that a little bit in another video as well. Okay, so it's pulled out in the glomerulus. Now it's pulled out. It's called filtrate. So it's not the stuff that is not the red blood cells, the platelets, the large proteins, right? It's pulled that out, it's filtered it, and it sends it in through the tubules. Again, there's a lot more detail to this, but we don't need to know like all of that detail. Let's just kind of go through the basics, right? And so that filtrate now is going through this tubule here. And what happens is that those tubules will start to filtrate now. That filtrate will start to filter it. So it's going to reabsorb certain substrates or substances back into the capillaries. So those would be usually electrolytes, glucose, amino acids, and so on. And then at the same time, some more substances are passing from the capillaries into the tubules. So remember I said not everything is filtered here in the glomerulus. Some things are going to be filtered here as well. And so, things like hydrogen ions, creatinine, those are being continually filtered out of the capillaries into the tubules just throughout this process here. Okay, you don't need to know more than that. It happens pretty much along the entire length of the tubule through the loop of Henle. The loop of Henle, which is this part right here, right? The loop of Henle kind of does, different things depending on where you are in the tubule, but we're not going to go into that. What's really important to understand is that it's permeable to water and sodium. Okay, so this is where we are, this is where all of the urine would be, like because we're talking nephrons, right? Like these are tiny, tiny little units, but in each one of them, when you put it all together, this is where the urine is concentrated. So this has to do with, so I think I went into a bit too much detail yesterday because I think it was almost confusing, and you don't need to worry about it. The point is that is where it is concentrated. And yes, it has to do with your antidiuretic hormone and so on. But the reality is that we want the body to be able to concentrate the urine at an appropriate dilution, and then release it out of the body or excrete it out of the body, right? So if this is damaged here, if the tubule or what have you, and we talked about that when we talked about acute tubular necrosis, right? If that's damaged and it's not working properly, it's responsible for collecting fluid and using it and putting it into the urine. So if it's not working, and of course there's all the renin, angiotensin, aldosterone kind of cascade. But the point is, if it's not working, instead of the fluid concentrating the urine and coming out in urine, the body will retain it, right? And we'll talk more about that in other videos. I got to remember, this is just like a basic overview of what the kidney does. Sorry. But the other thing is that this part also is responsible for, or partly responsible for, your acid-base balance in your body, right? Because I talked about how part of what's coming out of the capillaries and into these tubules is hydrogen ions. And as you know from your acid-base balance, that has a huge impact on your body's acidity. We can talk more about that in another video as well. One of the other things that tubule does is it is responsible for reabsorbing bicarb. And if you remember from your acid-base balance, bicarb is one of the, or the major, whatever, but it's a huge player in terms of working against acidity in your body, or alkalosis, right? So again, just understanding, I even what I just said now might be too much detail, I don't know, but just understanding that the blood is being filtered here through these nephrons. It's pulling out the things that things that are going to go into the urine and be excreted from the body, and it's keeping the things that we need, certain electrolytes, amino acids, and glucose, and what have you. Okay, and that's that for that video. So if you were struggling with just kind of the basic anatomy and what the kidney does, hopefully that will help a little bit, and I will see you guys in the next video.